Hello, everyone. Welcome to this live episode of the Data Binge podcast. Thank you for joining. We have an amazing guest here with us today. So excited for this. Brandon Rohrer, principal data scientist at iRobot and instructor and founder of E2E ML. Brandon, what is giving you energy today?
Hey, Derek. In this very instant, broadcasting to people is giving me a lot of energy. I tend to be pretty quiet and I enjoy coding with my head down. But for some reason, speaking to people always just pumps something up inside of me. But it's a beautiful day here in Boston. Took a little walk this morning in the public garden. The leaves are starting to turn. And it's just a good reminder that life goes on. Even when a lot of things feel like they're on fire, there's a lot of things that are also kind of quiet and beautiful and exciting. And so being able to balance those is kind of one of my goals for today.
Very good. Very good. Well, I'm just so thrilled to have you on. I've been hunting you down for a handful of months. The way that me and you connected is we have a mutual person of interest in our lives, a good friend of mine, Dallin Rohrer, and your brother.
Yes.
And apparently I thought no one could be any nicer than your brother, Dallin, but I think you may take the trophy for that. So it's wonderful.
That's a big compliment. Dallin is pretty dang nice and pretty dang sharp. So
yeah, I would agree. So a lot of folks are coming in. This is a live discussion, so feel free to ask questions, make comments. We'll do our best to address those questions and comments throughout the live feed. But let's just jump right in. Brandon, what do you do today at iRobot, and how did you get to where you're at today?
So I'm a data scientist. I'm an individual contributor. I work on a team of other data scientists, and our job is to help your Roomba be a little bit better at its job, to be able to get your house a little clean, a little cleaner, a little faster, a little less help. And it's really very satisfying. Robots have been an area of interest of mine since I was a little kid watching The Empire Strikes Back and Luke getting robot arms and talking with his robot buddies. And the arc of my training, of my professional work, has finally landed me back in a robot space. But to get here, I do a lot of work with data of all sorts, all of the things from finding it, figuring out what it means, cleaning it up, to assembling it into models to tell us things that we didn't know before, and then help the customer, whoever that happens to be for the company that I'm working at, have a better experience as a result.
And what's really interesting about your journey, we talked before we got on to this live discussion. You started data science around 7 years ago in your first role. You bring with you some pretty handsome accomplishments, a master's in science and mechanical engineering from MIT, a PhD in mechanical engineering from MIT. So how does one, a mechanical engineer, someone who's probably around an ecosystem of robots and things we're going to talk about in this discussion today, how does one even get into this world of data science?
My path is a good example of how broad data science is, how broad a net it is. It has more to do with the tools you use than what you use them on. So although my degrees were in mechanical engineering, my doctoral work was taking data that was gathered while stroke patients held a robot and made movements during therapy. So with this robotic therapy tool that was also a measurement device, they were able to make improvements that were not seen before, but that were tricky to quantify. So I got all of this information from all of these stroke patients, and then I got to try to tease out how to measure, how to quantify, how to argue that this recovery was meaningful and real and large. So I was doing data, I was filtering, I was organizing, I was figuring out how to move it from one place to another, like all the nuts and bolts engineering that has to be done. And then I was looking at feature extraction. I was looking at algorithms to try to get at the substance underneath this. I had a string of projects like this during my 11 years at a national lab, also doing robotics, doing computational methods. The common theme was we've got some information, whether it's measurements or images or audio or heartbeats or something. We want to be able to pull out something from this that we can use to do something useful. In every case, the challenges were different. And I had to bring in new tools. I had to learn about algorithms that I had never studied in grad school. After doing that for a while, I was looking for a new position, and I saw a posting for a data scientist. And I thought, hey, all these things that they're asking for, these are all skills that I've acquired along the way. Maybe I'll give that a go. And it turned out to be an amazing fit. So even though my titles have changed dramatically, the nature of the work that I do has actually only evolved very slowly. The common theme being pulling out the interesting bits of data.
And just to magnify on that evolution just a bit, so looking at your LinkedIn profile, you did some work in plant genetics at Pioneer, a DuPont company. Had some time at Facebook, spent some time at Microsoft. Now you're at iRobot. And just a personal anecdote, when I mentioned who I was talking to today, a data scientist at iRobot, my wife said, "Ooh, I want to watch that one." She loves her Roomba. So I know exactly what kind of a refresh cycle we have if I want to have a good year in my personal life. So a lot of exciting things there. Why, from that evolution, from the time that you first started looking at feature optimization and modeling, what has changed, if anything at all, or what and why do you think data science is so important to our world right now?
So as statisticians or statistical analysts or quantitative analysts will be happy to tell you, data science as work has been around for decades. We've always had information. We've always had to try to predict things from it. The devices that we have to collect information and the ways that we have to store information and transmit information have just scaled up dramatically over the last 2 decades. And so with large changes of scale of 1,000 or 1,000,000 times, the methods and the tools change too, and they start to kind of get enough inertia that it becomes its own discipline, its own area of focus. And so it has evolved into a thing called data science that we collectively are still trying to decide exactly what that means and what is data science and what's not. But because of that changing over time scale of years rather than decades, it means that if a company wants to hire someone who is a, put in quotes, expert data scientist, they might be looking for someone who's only been doing that job for a few years. And so it means that there is both a lot of uncertainty, like a lot of people don't know what they're asking for when they want to hire a data scientist, but there's also a lot of opportunity because it means that if I'm just wrapping up a graduate degree in geology, but I used some numerical tools in my analysis and in my research, then I may be a good fit for a particular company. And so doing that matchmaking is a little bit messy, and there's a little bit of trial and error, a little bit like dating, but there are good matches to be had. And so it makes it, there's no clear-cut path, but there are lots and lots of paths out there.
I like how you paid some attention to the hiring process, because a lot of the customers we work with, and I'm at Microsoft, and so many of them are looking at us to help them with their hiring decisions for their data science personnel, these data science positions. And there's, like you said, there's so much there, and it's an evolving role. And there's the data engineering and the modeling and all these different aspects of that context. And on the last episode, I interviewed 2 co-authors of a new book called The Talent War. And it's essentially how businesses should have a talent mindset with how they hire. And we talked about hiring for very technical roles, and data science came up. And one of the authors said, we worked with a well-known business, and we were going through their experience profiles of why they were hiring certain data science roles. And one of the experience metrics that they had to have was, I think at the time, 8 years of experience with Python. But the executive was like, well, Python hasn't even been around that long. It's only been around for 5 years at the time. So it seems like there's a lot of over-indexing on certain technical skills in the data science world, and it's a hard world to navigate for everyone. So we also talk about this idea of solving very difficult problems, and that's a pattern I'm recognizing from you. What do you like about difficult problems, and what is your framework for how you approach?
It is true. I am motivated by a hard problem, and I have noticed it took me by surprise that not everyone was that there are kind of different things. Some people are motivated by getting very good at using a particular tool and being able to do that over and over again. But if you have a problem that is you come to me and you say, hey, this problem is important and it's really tricky. Can you please work on it? I'm like, it's almost impossible for me not to. The biggest example of this in my professional history is how people think. So trying to get a robot to do even some of the simple tasks that people do is really hard. Sometimes it is the simplest tasks that are the hardest. So when you deal with physically, say, something as simple as taking a key and inserting it into a lock is something that we expect a child to be able to do. There are child's toys where you do that. Sure, they're big plastic keys and plastic locks, but toddlers are sitting there doing that all day and turning it to get things out. To get a robot to do that is extremely difficult. And it raises the question, well, why? Why is that the case? 10 years ago, getting a machine to say, hey, this photograph has a bird in it somewhere, that was considered a very hard problem. And the question of like, well, why is it so hard? Because we do it without thinking, but we can't get a machine to do it. So that's a really good example of a problem that through immense application of research, resources, and kind of academic focus has, to a large extent, been solved, at least that very simple case. But there's a lot of physical things that on their surface are even simpler that still have not been solved. Those problems for me really get me going. So one thing I enjoy playing with in the back of my mind for the last going on 20 years now is if I wanted to make a brain that I could just drop into any robot and it would figure out how to kind of move around and do a few simple things, but it wouldn't have to know anything about the robot beforehand, how would I do that? And this is, I'm not the only person who's thought of this problem, not the only person working on this problem, but it's still a problem that is far from being solved. And for whatever reason, it's not a problem that gets a lot of direct academic attention. And so probably because it's difficult to measure success. So it's difficult to publish papers on. But it's something that is that really excites me. And so a lot of what I do, whether it's at Microsoft or Facebook or at iRobot, I always in the back of my mind, I think like, how would I apply this to this hard problem of getting a robot to do the things that we humans do so naturally?
So it sounds like there's like very much a design thinking, just a very much a human element to the approach of how you kind of anecdotally approach the robotic problems and how to look at robots. Is that something that you think is within your ethos and you just have a passion for these types of items? So you take the space, you give yourself the space to think about the design and how those things come together?
I think that's probably a good way to put it. Complementing that, I also enjoy feeling confused about something, like having something that is so hard to do. Say I want to get a computer to be able to understand what I'm saying and be able to respond in a reasonable way. That's really, really hard. People are making a lot of great progress on that problem, but it's still very hard to do at a human level. But we know that it can be done because people do it all the time. Children do it. They figure it out without the benefit of gazillions of hours and trillions of GPU hours, and they just kind of figure out how to do this. So we know that it can be solved, and we're all examples of that solution. With the solutions between our ears. Why we can't get a machine to do it with those types of resources is a huge unanswered question. And I love that feeling of being just like mystified, and as opposed to feeling uncomfortable and needing to explain it away. So I guess that's something else that draws me to big problems. The fact that they're not solvable right away is not off-putting for me.
Speaking of mystification, so I have two kids. I have a 2-year-old son and a 3.5-year-old daughter. And I'm reading this book called The Scientist in the Crib. And one of the premises at the beginning of the book, the general hypothesis, is that we forget that there's like a hard-coded DNA. There's like certain algorithms programmed into these beings when they come into the world that allows them to learn language just by listening, and to be able to function and look at, facial expressions and depict and predict emotional responses. And it's just such we forget and take for granted how truly intelligent and immense the human mind is. And before we go off into robotics, we have a couple comments. So Ryan Swanstrom, he's mentioning data engineering is huge. It gets a lot less attention than data science does. Paul McLeod is agreeing. There's a lot of data science washing and AI washing at the moment. So they're talking about this whole idea of, this changing context of the role. Ryan mentioned getting robots to do very simple human tasks. That's very hard. So he's commending you for that. And Dallin is asking about the most interesting application of intelligent robotics in our near future. So let's talk about robotics. We know why you love it. What's the difference between robotics and machine intelligence? Can we get into that world for a little while?
Yeah. So I won't pretend to have any really crisp definitions for these. These are words that are helpful, but you can, depending on who's using them, they can mean different things. But some of the distinctions that are useful to consider: robotics is just, you got a physical robot moving around. It's a chunk of stuff and motors and gears and a gripper or something, and it's probably got a camera on it, and it's doing things. There's different ways you can use it. One, which is historically very popular, is you can program it precisely. You can tell it exactly to the sub-millimeter where you want it to be when and what you want it to be doing. And that's very useful for a lot of tasks, especially in manufacturing. So not disparaging that at all. It's one good way to use robots. It's not what I would call intelligent. It's not making any decisions. It's not making any judgment calls. It's just doing exactly what it's told. Machine intelligence is something that could be applied to robots, can be applied to lots of different domains. And it's this notion that you don't know exactly what situation your machine or your app or your whatever it is going to run into ahead of time. And so you give it strategies for handling whatever gets thrown at it. And not only that, those strategies are adaptive. So if something happens and it tries a certain response and that doesn't work so well, it might try a different response next time. It's still technically being done exactly what it was told to do, but what it was told to do was to pay attention to its experiences and to change as a result of those experiences. And that's when it starts, at least on the surface, appearing intelligent and starts to merit the term machine intelligence. The actual, philosophical discussions as to what intelligence is are outside the scope of my expertise, so I won't try to touch that. But I enjoy the intersection of these two things, of physical robots bopping around and doing so in a way that's adaptive. Based on their experiences, they bop slightly more intelligently the next day and do that day after day.
So one of the videos that I continue, and I think I don't know how I caught this video from you, whether or not you posted it earlier this year or I just saw that you were brothers with Dallin, so I wanted to kind of dive deeper into what you were doing at the time. But it was this entire idea of it was a 45-minute video or so, but it was machine intelligence and robots, why they're different, and you really went deep into neural networking and different types of learning capacities, machine learning. You talked about custom vision and vision properties, and covered just a huge gambit of what machine intelligence could possibly mean. And he talked about general intelligence and the difference between human intelligence, machine intelligence. You talked about, I think you called it fake math, intelligence equals performance times generality. Could you get into that discussion around your opinions and your perspectives a little bit? Because it was extremely eye-opening for me, and I think it will be for this audience as well.
Cool. When talking about intelligence, it's common to talk about it in terms of narrow versus broad. What that describes is the set of things that, we'll pretend we're talking about a physical robot, the set of things a robot can do. So for instance, if I have a robot that's really good at putting lids onto bottles, and it can do that 1,000 times faster than a human can, I would say that robot's pretty good at its job, but that job is very narrow. If you do anything different, if you can give it a slightly different size lid, it might fail. On the far end of that spectrum, the classic example of breadth is a human. Humans aren't good at everything that could possibly be done, but we do happen to be pretty good at all of the things that are useful for keeping humans alive. And in a physical world that's changing a lot, that is a lot of things. If you were to even sit down for 15 minutes and just make a list of all of the tiny things that you do in the course of a given day, all the decisions that you make, all of the judgments that you have to make, each one of those is a pretty challenging problem for a computer. So this spectrum between narrow and broad, it's not either or. So you can have systems then that are just slightly more broad. So a good example of some middle ground is a self-driving car. So a self-driving car, it doesn't have to figure out how to pour itself a bowl of cereal, but it does have to figure out where the edges of the road are. And the edges of the road can look really different depending on where it is, what time of day it is, what the weather is, what else is in the way, if someone has their trash out on the curb, things like that. Even more importantly, a self-driving car needs to know what a person is, what animal is, all of the things that it should not drive over. It has to be able to recognize all of those things. And that's a really big collection of things to be able to recognize. Again, at all times of day and all weather conditions, and maybe even like with a broken camera, if one of its cameras goes out, it still needs to be able to do an okay job at that. That is much broader than screwing lids onto bottles, but still much narrower than all of the things that you and I do. So what you can do is you can measure this intelligence, whatever it is, whether it's a robot or a computer program or something else. You can measure it on two dimensions. How broad is the set of things that it can do versus how well can it do them? And a convenient way to measure how well is compared to a human in some way. So if you take, say, a chess playing computer program, that's pretty narrow. Arguably in chess, you see a wider variety of situations than you would in checkers or tic-tac-toe. So that's a broader problem than checkers or tic-tac-toe, but it's still very narrow compared to the space of all the problems in the world. So chess is narrow, but performance is, I mean, the dumbest computer programs can easily beat the best human chess players at this point. It's not even close. So way superhuman performance. As opposed to self-driving cars, which are still narrower than humans, and also, depending on who you measure, how you measure and who you ask, they are either a little bit worse or a lot worse than human drivers. So still not quite there. And so you can look at different machine intelligences this way and compare their generality and their performance to get overall level of intelligence, roughly.
And based on your work and based upon kind of, you're probably operating, there's certain things that you can do with what the tools we have today. And I'm sure you're having ideas around things that you would like to approach in the future. We get some comments in from, Paul's asking questions around how do we teach robots philosophies like intrinsic senses of pain, life harm. You start kind of getting into the Hollywood of robotics. Are there specific limitations that you think organizations or people who are trying to do really great things with machines and robotics, are there things that they should just not attempt for now? Or are there things that are just completely out of scope, or things that are starting to become in scope that you're seeing with your work?
So with the caveat, these are 100% my own thoughts and opinions. Yes. There's two sources of worry that I've seen. One is that robots and artificial intelligence agents will just get so smart, they will either be hostile to humans or not care about humans, and apocalypse ensues. I'm really not very worried about that. One, because that gap in intelligence is still pretty big. And two, because the other source of worry is much more immediate, which is that artificial intelligence and robotics are tools. They're like the wheel, or they're like fire. They're tools that are expensive to develop and maintain. And so they tend to be tools that are directed by a few companies with lots of resources, governments with lots of resources. And anytime that happens, there's the danger that people will just do mean things to each other. Not to make it overly cutesy, that people will be cruel, or at least that they will look out for their own interests, ignoring those of, others, another company, other people of a different socioeconomic status, people of a different nation, and they will knowingly or unknowingly allow them to come to harm, while doing all of the things that they are ethically bound to do, like maximize shareholder value or ensure the security of their citizens. So I am concerned mostly that in partnership with people, these tools can be used to hurt other people. Facial recognition is one technology that, in my opinion, is very easy to misuse. It is not inherently a terrible thing. I can think of situations where, say, in my household, I would love to have a camera that could tell the difference between me and my other family members and, adjust temperature or lighting accordingly. That would be entirely appropriate. If that system were to not behave well, the outcome would not be catastrophic. But using it to do predictive policing, especially with the huge limitations in its current performance, is just unethical and tends to disproportionately harm people who are already harmed a lot and at a big disadvantage. So my biggest worry is in who is using these technologies and for what purposes, rather than the technologies themselves. And that's not a problem that technology can solve. It's a problem that we as people and as governments have to solve working together.
We hear so much that in the news. Now you have these things like deep fakes. I think I just saw an article specific to Microsoft. I think we as an organization may not be providing some of our AI technologies to law enforcement or some sector of government or organization to just prevent the misuse and the wrong use of certain technologies. I think a lot of companies and organizations are starting to do that. What's interesting is you see these things evolving, like what's happening in Japan. And I'm sure you have familiarity to all the things that are happening there with some of their robotics and their culture of robotics and technology. But they have this I read a piece of documentation on Society 5.0 in this idea that humans should work alongside with robots. And then they have these kind of philosophies, axioms, whatever you want to call them, around what we need to start doing. And it's, educating younger students and helping them understand how to work in parallel with AI and use AI's tooling, and providing massive data sets, making massive data sets public, kind of concentrating on a certain regulated languages, programming languages, so that everyone has access. And are there, we're kind of getting into the funner part of this, the tail end of this discussion. Are there things you think should be done at a national level, at a government level, organizational level, that would make it easier for folks to truly democratize the opportunities behind some of this technology?
One of the most radical things that I can think of is to make technology education available to everyone, because the wider spread the knowledge is of what these technologies are, how they work, the ability to deploy them, the lower the risk that some privileged group or powerful group can at least disproportionately use them to harm another. It levels the playing field. And this is something that I find I'm highly motivated by. I enjoy taking ideas that they're confusing and they're frustrating. I know, because I have been confused and frustrated by them, and breaking them down into terms that I would have liked to had available to me when I was learning them. And I enjoy doing that. And then I share those, explanations to my past self. I enjoy sharing those around and hearing that other people say, wow, this really helped me to kind of have this concept click. That makes me really happy. That in a small way feels to me like, at least here and there, are sparking like this ability everywhere. And it takes the focus off of technology as kind of like an evil, like, fire as an evil, but puts it on like, well, how is it used and who's using it? Like, that's what we need to pay attention to. Also, if more people are aware of its limitations, like, that's power too. Like, there's less and less of a tendency to set up the algorithm. It's like, well, humans can shrug and say, I don't know, well, the algorithm said, it's not my fault. It's not my country's fault. It's not my company's fault. People can say like, oh, that algorithm was something that is adjustable and something that you chose to use. You are accountable for this. And I know, because I know a little bit about how it works, or I know enough about how it works to build my own version and to, show that this is not the right way to do things. So that's something that I think is powerful to do. I don't know, despite a lot of attempts to do this, I don't know of any nice ways to remove the need for technical knowledge, unfortunately. To wrap your head around how some of this work, it does require some investment. It requires learning a programming language. It requires being able to do a reasonable amount of math. But the difference being, if these educational materials are available to anyone, at least anyone with access to the internet, then that lowers that bar. There's not a wall of, you have to be able to pay an exorbitant tuition. You have to be able to travel to a university to be able to get this knowledge, which for me is unreal. I remember in grad school going down into dusty basements to photocopy articles that were already 50 years old, at 10 cents a page. And occasionally you could find an article in PDF online. And that was just so revolutionary. And then since then, a lot of universities leading the way, putting their course materials on video online. Almost all papers, if you're creative, you can find copies of online. We are at a point where there is no reason for everyone not to have access to as deep of an education as they have the time to invest and extract.
You talked a lot about, and I think we have a lot of people just generally who are afraid of losing their jobs. I think I read something that majority of mid-level professionals, in their 40s and above, one of their deepest anxieties is just not understanding, not knowing, not being able to catch up, and being irrelevant. And we're talking about like the ability and access to education, and just in upper education, private and public school, or public and private school, 25 and 28% increases in a 10-year span of tuition costs, respectively. It's expensive to go back to school. It's expensive to go to school in the first place. You mentioned winning the lottery, essentially, when you talked about kind of your opportunities at MIT and what that looks like. And that's why you're focusing on a lot of this instruction, and we'll get into that as well. What can folks do before we get into learning completely? What can folks do you think? What mindset do you need to get into something new, to explore a new sector, a new level of education, to pick up a programming language, to understand technology? Is it more of a mindset to you? And if it is, what do you think that is?
Yeah, it's terrifying. We have a lot of pressure not to be wrong, not to say the dumb thing, not to make mistakes. And if someone can say, here is a path, and if you do all of these things, then you'll be safe, and you can get from A to B, and this is how the process works. Some fields, perhaps, this is still feasible to do, but especially in the area of data and technology, it's changing too fast. And change is an opportunity, perhaps. It breaks some things down and it builds some things up, but change, for whatever reason, is almost uniformly painful for us. Having to change, especially having to move away from something that we are good at to something that we are not good at, hurts. One of the most liked tweets that I put out once was just something to the effect that learning is just a series of instances where you feel dumb and you feel like you don't know what's going on.
Yeah.
It is, I don't know of any shortcut around that. I don't know of any level of explanation of new concepts that help them not feel bewildering the first time. I don't know of any way to, when you do something for the first time, for it not to feel confusing. So yes, for me, there are a couple of mindset tricks, I guess, that really pave the way for this. One is I always assume that I'm wrong. I release videos and tutorials and course materials, and I can't wait until I'm certain that I'm right, that I haven't made any mistakes, that I haven't mispronounced anything, that I haven't gotten any equations wrong, that there's no bugs in my code. Because if I did, I would never produce anything. And, luckily, the internet is really good at pointing out instances when you're wrong. So you get to self-correct. And I try to do that publicly and transparently to model that. But yeah, I consciously release things when it's at the A- level, like pretty good. But if I were to try to get it to the 99+% level, nothing would ever happen. So getting comfortable being wrong, getting comfortable making mistakes is one thing. And also knowing that feeling lost is normal. That doesn't mean that you're doing it wrong. The big thing, those are fairly negative. Those are pretty hard. The other mindset thing that for me is a huge positive is knowing the flip side of that. Nobody knows what they're doing. Everybody is faking it. Not just in data, but everybody is making it up as they go along. Some people are doing it very confidently, so you would never guess. But what that means, that comes with tremendous freedom, is you can look at a field, look at a problem, and with confidence, you can say, well, my instincts say I should try this, or I want to learn this, or I would like to try to get into this field. And if you feel something and you're someone's naysaying, just say, you know what, this is something I feel strongly enough. I got to try it. Maybe I'll find out that I'm wrong again, because that'll happen a lot. But I need to jump in. I need to pursue this problem. I really want to solve this thing that has caused me pain or someone I know pain. And even though it hasn't been solved yet, I need to push on that. So that freedom to do that not looking for some absolute authority to tell me when I'm doing it right. That's been very liberating.
Thank you for this, Brandon. And it seems like there's a lot of folks that are enjoying this portion of the talk. Ryan is saying, education for all. You can really see the passion in education within you. Chetan, blockchain and AI at NEC, getting comfortable with being wrong. Thanks for saying this. Paul's been commenting throughout the discussion. He's loving it. And Tony, he came in and says, don't be afraid to ask questions. So I got to go here because we're already here. When it comes to, you're talking about putting things out into the world that could be wrong. And especially now, there's a lot of fear. I deal with fear constantly. I'm afraid for the majority of these calls I get on, these live discussions I get on, like when you're putting yourself out there, when you're doing things that are new, there's so much fear there. Is there a fear management protocol you have, Brandon? You're putting out a lot of content. You have over 68,000 subscribers on YouTube. You just hit 10,000 students on your instruction website. Is there something there that you do to overcome fear?
That's a good question. I've actually never thought about it so directly. I think that the one trick that I have found is not to measure my success in terms of likes or subscribers or positive comments. And so I really pursue things that I'm personally interested in. So if no one were to ever watch it for some reason or pay attention to it, I would still be glad that I did it. That's a lot more satisfying because it leaves me less at the whims of other people. There's definitely times when I have to close the lid of the laptop and walk away. Like the anonymity of the internet is, a really safe place for people who enjoy making other people feel bad. And so there's always a jerk. There's always people saying things that are either overtly or like in these very like academic passive aggressive ways, looking for ways to cut you. As a guy on the internet, I get a lot less of that. I understand from my friends on Twitter that if you are female in doing this or a person of color in doing this, you can multiply that by 10 or 100.
Wow.
And I have so much respect for the people that brave that to continue putting content out in the face of all of the garbage that gets thrown at them as a result. So that takes a certain level of thick skin, and it may mean that publicly publishing things is not where you want to start. Like it would be a very personal thing. But I also try to limit my the hold that other people have on me. Like I don't hold myself responsible to responding to every comment. Someone's being a little bit rude on a social media platform, I just block them or mute them. I just remember that they're kind of not people I want to make happy in the first place. So why do I care? I did want to call out one interaction I had recently that was notable. Someone made a comment on it was a small technical post that I had made. And the comment was a little bit challenging, a little bit in your face, but not over the top. So I ignored it for a bit. And then I came back to it. I'm like, I'll give it a benefit of the doubt. And I gave it a short but thoughtful response. And it turned out that engaging with this person a little bit more, they are autistic. And they expressed in subsequent posts, like, I have so much trouble interacting with people, and I know that I come off as a little bit rude. I don't mean to. Like, this is something I'm strategizing how to overcome. So I was happy that in that particular case, I pushed through. But it is, I don't want to overplay that. There are a lot of people who don't deserve the benefit of the doubt. Like, one strike, you're out is absolutely fair rules for any kind of online interaction.
What an amazing lesson that was. Just such an optimistic, it's hard. Even having that frame of reference as you continue to look at comments and things like that, that nature, that's really going to help you kind of steer through those things. I appreciate you sharing that. So let's get into learning. Ryan posted a question before the discussion around how do you teach kids to work with robots? How do you teach robotics to children?
I like that question. I also want to shout out to Ryan Swanstrom, who is a world-class data science educator and advocate. He's been doing this for quite a while, and he's very good at it.
Yep.
I just only loosely related. We recently gave as a gift a copy of this Bayesian Inference for Babies book, which actually shockingly well had a great example of Bayesian inference using chocolate chip cookies. So so there are concepts that are big and have scary names. Sometimes those scary names are there so that the people working on them can feel good about themselves. But also some of these things are really complicated. Anyone who has done anything with data engineering, there's just a lot of moving parts to get petabytes of data from one point to another, just to copy. So these things are not trivial. But teaching, if I wanted to get a 5-year-old or a 10-year-old excited about robotics, I might not start directly with robots themselves, but with the concept of building, of creating, of figuring out how things work, and going from there. Also really being guided by what they're interested in. So I have had 5-year-olds and I have had 9-year-olds of my own. And I got the, Lego Mindstorms with the motors and everything. And we built some things and it was kind of fun, but it just didn't really take. And that was okay too. So one of those 5-year-olds is now a freshman in college learning MATLAB for the first time. So we're revisiting some of those concepts. But robotics is like a specific thing. Some people might be excited about it, some might not. But what's general is curiosity, the comfort, building in that comfort of being wrong, of exploring, of doing something that doesn't work, or of doing something differently than the instructions say, and seeing what happens. Removing those guardrails, those messages that some of us get from very young, that this is the right way, and saying well, what do you think? There's A, B, and C, try them out and see what you think. Maybe stack them in the other direction. Maybe, maybe don't let the glue dry for 2 hours and see what happens. It's those types of things. Then this child may not end up being excited about robotics, but whatever they do end up being excited about, they will dive in and jump in with both feet and make a difference because they will be freed up to do that.
I forgot. So what you're saying, it's like these fun, you talk a lot like, Richard Feynman or some of these types of folks that are able to make things so foundational. And I remember he gave a lecture on heat and he talked about atoms and how atoms were really these dancing things. And the more they danced, the more heat they conducted. And I can't pour a cup of tea or coffee without thinking about the atoms. So that was just a 30-minute snippet I watched, and I'm going to take that with me forever. So it's just brilliant, I think, and you're very good at this, Brandon, of just fundamentally communicating the very, very simple outcome of this very complex idea. And with that, I'd like to talk about your what do you want to call your online workbench?
Oh yeah,
E2E ML. I'd love to talk about this. What is it? How did it come about? Let's get into this thing.
Yeah. So end-to-end machine learning. For lack of a better term, it's in a platform I call a school. It's somewhere between a blog and a book and a video series. And there are things, for lack of a better term, we call courses, which tend to be usually maybe an hour to 2 hours worth of videos stitched together some text and posts in between, some code related to it. But the focus of all of this, a couple main themes, is that it doesn't matter where you are on, this line from knowing nothing to being front of the field researcher in machine learning or neural networks or data science or anything. Like, you can take the next step. None of these concepts are unattainable. None of these things you have to have someone else's permission to understand. All of it can be explained. It's all knowable. So right now, if you picture this, wilderness, this thick wood, we were talking about Tolkien earlier. So an impenetrable wood, like Mirkwood, from one side to the other. My goal is to pick out a path along it. So anyone who wants to get through this wood has some markers that they can follow. They can go as far as they want. And then even better, you can get halfway in and start striking your own paths out to the side or take shortcuts. The most powerful way I know to do this is with projects. Rather than going through encyclopedia style and learning all of the features of a language or of a method or of a tool, to be able to say, we would like to achieve this thing that might be interesting in the real world. One of the projects is predicting whether or not to buy plane tickets. This was pre-COVID, when buying plane tickets was something reasonable people would do. And based on weather reports and making weather predictions, and that gets very quickly into time series prediction and getting features through auto-regression and building things in Python and a bunch of fun technical details, but it is always with this goal in mind. That's what the end-to-end implies in end-to-end machine learning. On the leading end of that is, where do we find the data to do this? What steps do we have to take to make that data amenable to crunching in our Python algorithms? And the ability to go, again, like follow, in a slightly different sense, follow this road from the very beginning to the very end to achieve a goal. Then if you have a similar goal in the future, you can deviate from that. But everything that you do will have been based in some practical need. That's how I like to learn. I like to have a problem that I am trying to solve and learn what I need to get there. Instead of, you can imagine the other way is you come up to the edge of Mirkwood and you slowly start clearing off one row of trees and another row of trees and try to progress your way through the whole forest. You'll never make it. It's a much slower way to go. So
there's also a ton of spiders in there, and it's
you gotta watch the spiders.
you gotta watch the spiders.
Right.
Yeah, that we for folks that are listening in, we just got to know each other a little bit before the discussion, and both Tolkien fans, and nothing brought a bigger smile to me than knowing that, Brandon, your favorite book in the series is The Hobbit, which is my favorite book in that series as well. So that's really fun. That's really cool.
A good story.
Yeah.
But yes, the other part of the on the end-to-end machine learning content is it's a mixture of free and paid. My philosophy being, again, spreading foundational knowledge should be generally available. The basics are all free. The specifics, the code walkthroughs, the diving down into the nitty-gritty, those are things that someone sufficiently interested and motivated could do on their own, but as a convenience, we can do that together, and that's the paid content in the lessons. So yeah, we recently had our 10,000th person join, which was something I was very excited about, and look forward to interacting with even more in the upcoming year.
I mean, I looked at it while I was doing some research on this discussion, and I was just very surprised at the availability of being able to just click on some things and just get you to be walking me through very, very basic concepts. So I'm just so appreciative of people creating educational opportunities that you can access as long as you have a broadband connection, and it's there's no barrier to entry, there's no cost. So that's just really cool. I know we're getting short on time here. What's next for you, Brandon? You have this school. You're doing some amazing work at one of my wife's favorite companies on the whole planet. what do you think is next for you? It could be in 10 years, whatever.
I am really excited to things at iRobot are just continue to grow. I have a fantastic set of teammates that I get to work with in a fantastic larger organization that values what we do and gives us a lot of encouragement and support. And then continuing to produce content on end-to-end machine learning. Just those are all the things that just really kind of like get me excited professionally and keep me interested. So more of the same, full speed ahead.
Very good. Very good. And then one last question. If you had unlimited resources in 7 days to execute those resources against some topic, what would it be?
Oh, unlimited resources in 7 days to dive in. I have no idea. All I can think of is that if I had unlimited resources in 7 days, I would sit down someplace very quiet with a nice drink and read The Hobbit. I'd probably come up with something more ambitious after those 7 days are over.
Yeah, that's it. That's a great answer. How do folks get a hold of you, Brandon?
My personal email is just fine, brohrer@gmail.com. I'm also on Twitter and LinkedIn. And then, of course, a quick Google EML.school will get you right to all of the fun content.
That's awesome. Well, Brandon, this has been an absolute pleasure to have you on. Really appreciate you. And we'll go ahead and make all the different links we discussed available in this particular chat. When it publishes to the Data Binge podcast via audio, we'll make it available in the show notes. And this was really fun. I'm really glad we were able to do this.
Thank you, Derek. It's been a great time. I really appreciate it.